Dr. Stuart Hameroff, the founder of the theory of quantum consciousness. You make 31 conferences over this topic of consciousness. And you are on this field from the start. What can you tell about the evolution of this field? Because you saw from the beginning until today. What changed?
It's kind of diverted into two camps. One would be computationalism, based on materialism, reductionism, in which the neuron is looked on as a simple on-off switch, a 1 or a 0, like in a computer, and you make a network of these simple neurons, complex networks, and get consciousness emerging. I don't believe that, although it's consistent with AI and it's pushed by AI. They're probably promoting it because it makes AI more likely to be conscious, because it's no different than a computer, and if the brain's a computer, then why shouldn't AI be conscious? On the other hand, how would that explain a single cell like a paramecium, which has no synapses, which can swim around, find food, find a mate, have sex, learn? If you suck it into a capillary tube, it gets out faster and faster. It has some kind, it may be conscious, but it's definitely intelligent, and yet it has no synapses. It's not part of a network. So if a single cell can do that, why would a neuron be so stupid as to be only a 1 or a 0? And where is memory stored? It has to be stored inside somewhere, because there's no synapses in a paramecium, and it does remember. And even in the brain, the synaptic proteins last hours to days, and memories can last lifetimes. So I think memory is also stored inside in the microtubules.
Connected to that, you presented this edition something very important about your work. Can you tell us which is the grade of your work that you presented this conference?
Well, what's new is the time crystal idea, and that is something that was proposed in physics in 2012. And so a time crystal is a spatial crystal like quartz or diamond, has matter periodically arrayed. Regular spacing gives you new properties, like a diamond or quartz. A time crystal has dynamics, patterns that repeat at different times, different frequencies. So instead of a solid repeating periodically, it's a dynamic that repeats periodically in time and in frequency and breaks time symmetry. So you can have the exact same patterns at a very, very fast, small scale, and larger, which is, it looks like microtubules do that, which means that processes at the very tiny scale can percolate up and transcend scale into something as large and global as consciousness. And it also would explain the origin of life, because this could have started life, because life could be defined as a time crystal, actually. I think both consciousness and life itself may depend on time crystals, of which microtubules seem to be the best example.
You are talking about the microtubules, and when I was asked about, the psychologist asked me what is best metaphor to describe this. I imagine that the brain, it's like a large orchestra,
yes,
and the neurons are the instruments,
yes,
and the microtubules.
Well, I'd say the microtubules are the instruments.
Microtubules, instruments, yeah. And
the neurons would be like, okay, the percussion section, the violin section, well, except that's not good, because they're actually.
But maybe microtubules can be the string of the violins that are at some point are pitched, and the big conductor is the quantum process.
There's no conductor. It's more like a jam session or improv.
Okay.
And they just play off each other. So you don't need a conductor. You
don't need a conductor. So when the reduction takes place, we have the subjective moment of consciousness, right?
Right.
So when this reduction takes place, it's like from inside decision. Can we influence with our thoughts?
The collapse occurs on its own by a threshold that's tied to the fundamental level of the universe, which is, because I think consciousness is fundamental. So the basic components would be proto-conscious. They just have simple feelings, and then so they're like then the musicians in the orchestra are tuning up before they play. They're all you hear it's noise, but it's sound, but it's noise. It's not music. And then the orchestra begins, and it's music. So that's the difference between proto-conscious noise, which is everywhere in the universe, including right here in this table. But when it gets organized and orchestrated, you get music. And consciousness is more like music than a computation. The brain's more like a quantum orchestra than a computer.
So I understand you are talking about harmonies.
Harmonies,
not
resonances,
noise.
Interference, beats, which is very important. That's how you get from very fast to very slow.
Okay, so the last question. You launched yesterday a challenge about the holographic memory. In what way, which is the next move for your theory? How can it be integrated with holographic memory?
Well, holographic, even representation. But we know that memory is distributed. It's all over the place. And there was a guy in the early part of the 20th century who tried to find where memory is stored, and he would teach a particular trick to animals, and then he would look at their brain and wipe out this part, wipe out that part. He could never get rid of any memory. It always remained, even if he wiped out almost the entire brain. So that means the memory is stored in a distributed factor. And in a hologram, you make an interference pattern in a plate, and then if you re-illuminate the plate with a laser, you get the whole image. It may be low resolution, blurry, but you'll see the whole thing. You don't see one little piece of an image. You see the whole image. That's a hologram, and I think that's how memory is. So if you look in any one place, you can get the whole picture, but it'll be kind of blurry, and so that's how a hologram works. And Carl Pribram came up with the hologram theory, but they said, well, you need a laser. There's no laser. But I told Carl Pribram, yeah, you have microtubules, which are providing coherence, and that's your laser. So yes, consciousness could be a hologram, which makes a lot of sense actually, because it's three-dimensional, it comes from a two-dimensional surface, and it might be happening in the cortex.
Okay. So this is the next step, and I can't wait next year in your place to see you and take the next interview.
Okay.
Thank you very much, and I appreciate a lot the honor to have this talk.
It's my honor, my pleasure. Thank you very much.
Thank you.